Okay, so this is 2019 question 5. It's a HPLC question and it's for quantitative analysis. So we've got some sucrose and we've got different concentrations of sucrose, and you get different peak areas when you put them through the chromatography HPLC column. So you plot the peak area of your peaks against the concentration. You notice that you put a line of best fit so between all the points, and then the question says it's going to give you a peak area. If I just do here. So you've got a 5 ml sample. I'll read all of this, yada yada yada, because the first thing that you're always going to do is find out the concentration of the sample that you've tested. So determine the sucrose content. If you look up 1900, your peak area, so 1900, this is the most horrible graph because there's no kind of divisions. So you go up to the first 500, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So here, if you go across, use a ruler, you need a ruler, and then go down and you'll find that it's 0.3 grams per litre. Alright, so the first question's easy. Now we need to look up what the actual question is. Alright, so I'll just make this a bit bigger. Okay, so they got a 5 ml sample of soft drink and diluted it to 100 ml. So I've drawn a little picture to represent our 5 ml sample and made it really concentrated, tried to make it really dark, and then we've added water to it and made it up to 100 ml. So the sucrose that was in here, all the mass of the sucrose that was in here is now spread out, and the mass that you had in here is now in here. So this is less concentrated with the same mass. Then you've got a 10 ml aliquot of this was transferred to 250 ml and made up. So you got this of this concentration and you transferred it over here. So this 10 ml that we took over is the same concentration, and then you diluted it to 250 ml. And then we took a sample of this out and we measured the concentration of this. So this is our 0.3 gram per litre concentration, this really dilute one. So then it wants you to calculate the percentage mass in the volume. So when you've got percent, it's always the mass in 100 grams. So the percent mass in 100 grams. And you can work out the mass in your 5 mils and then just use your ratio to work out how much that would be in 100 mils. So we want to know the mass in here. So we're starting over here. We've got the concentration of the 250 mils, and this was diluted. So we can work out the concentration in the 10 mils. So your C1 V1 is your 10 mils, your C2 V2 is your 250 mils. So to work out the concentration in your 10 mils, you just take this over the other side and divide it. So you've got the 250 divided by 10, which means you're going to multiply, this is 25 times what you started with. So this is 25 times more concentrated than the 0.3. So in your 10 mils, you have a concentration of 7.5 grams per litre. That came from here. So there's a lot of different ways you can come back to this. You could work out that that's the same concentration that we just worked out. So the 100 mils and the 10 mils have the same concentration. So you've got 7.5 grams per litre here. You could then, because this was diluted, you could do another C1 V1 to work out the concentration of that and then work out the mass. Or you can kind of skip to working out the mass of this, because the mass that we started with in here is now all in here. So if you know the concentration and the volume of this, you can just work out the mass that's now spread out. So your concentration of that is the mass in the volume. So we want to know the mass. So we've got our 7.5 grams per litre. And I did a classic mistake. I realised it's 100 mils. So the first thing I did, I just wrote down, oh, okay, I'm looking at for the mass in the 100 mils, but this has to be in litres to cancel out the litres. So turn your 100 mils into, divided by 1,000 to turn it into litres, and then you find that you've got 0.75 grams. If you did it the other way, you'll get the same number. So you've got the concentration. If you did your C1 and V1, worked out the concentration in here, it would be a higher number, and you've got a lower volume. So if you're multiplying two numbers and one number gets higher and the other number gets lower, then you'll end up with the same thing. So you've got that mass in 5 mils, and percent's always out of 100 mils, so you can just use your ratio to multiply that by 100 to scale that number up, so that it's out of 100 mils rather than out of 5. So you would have 15 grams in every 100 mils, or 15%. Okay, so this question is just the same as the previous step that we did. You're just working out, calculate the mass, and you've got a concentration, so you just rearrange your equation. A volume, get used to putting the symbol over, I've got a volume. So you can just use your percentage, 15 grams in 100 mils, and you've got 330 mils, so they'll cancel and you'll be left with 49.5 grams. The answer really should be in 2 decimal places, significant figures I should say, not decimal. Significant figures, because your original concentration was 2 significant figures, so that would round up to 50. Based on the results obtained, is the experimental method valid? So valid means, are you measuring what you think you're measuring? So if we looked at their answers, it's valid because the data is consistent for standard solutions of different concentrations made up from pure sucrose. So they were basing what they were doing, their sucrose analysis of the soft drink, is it soft drink? Something, on that there was sucrose in the soft drink. That has to make it valid. So in order for you to know if there's sucrose in the soft drink, you would have put a standard of sucrose through a HPLC, and then the retention time that it came out at, the pure sucrose. So the time that the pure sucrose came out at, if you put your soft drink through and you get the exact same retention time with the exact same conditions, so the HPLC chromatogram was run under the same conditions, so same temperature, same length of column, same pressure, same mobile phase, same stationary phase, all the same conditions. You put your soft drink through and you get a peak at the same point, then it's valid to think that that's sucrose. So if you did your graph under all the same conditions, then you can use your graph. The other answers here, you've got a certain number of points and they're fluctuating, so to make it even more valid, if you repeated each of these points and then got a really good average, or if you do more points in between to make that line even more accurate. So the conditions being the same makes it valid if everything's tested. If you're comparing the standards to the unknown and you're looking at the same retention time, it makes it valid. It's invalid because not enough points were established. So it was not handled very well, this question. So 90% of people didn't get it.